So what we got going on this morning is we have a customer that brought in a, let's see here, 28-foot extra height trailer. This is a Hallmark Edge. It's a little older, 2009 model. You can see right here in the VIN tag. So it's about a 15-year-old trailer. It's actually in really good shape. The customer brought it to us because I got hit by a tractor here on the side door. Messed up the panel a little bit here, messed up the door, the frame. We got a little damage down here on the main frame. It's kind of bent in, messed up the trim. It's got the step a little bit. So what we need to do is, they don't make this trim anymore. They don't make this door trim anymore. So I'm not gonna be able to take this apart and just fix what we need to fix in the little pieces. We're gonna have to fully replace the door. With that being said, obviously it's a 15-year-old door. It's done very well. This is, I like the older trailers myself because they were built well, very high quality. They use a nice weather stripping in there, nice hinges, a bunch of hinges, extrusion for the aluminum. These extrusions here were built stronger and thicker than most. Back in the day, they've now substantially dropped their quality in that, for the most part, on most of the doors. So I'm gonna go ahead and show you what I got for the new door. We're gonna build a whole new frame that matches, because our extrusions that match the door and the frame are different than these. Plus we have some damage down here that we're gonna have to address as well. So we're gonna go ahead and do a whole new door, whole new frame, new hinges, and then the trim, we're gonna have to take the trim off, repair that instead of replace it. And behind the trim, the framing, we're gonna have to cut that out, pull that back out. This is when they double walled the framing on the underneath, so it's kind of like a box. So we're gonna have to figure out how to push that out and adjust that, on top of fixing the aluminum, polishing that back out, and putting some new DOT tape on it. So as you can see on this one, we just got done with these doors here. It's a little different framing. I'll show you guys how we do the inside of the frame. Well, we add extra reinforcements here. There's aluminum reinforcements that go in the corners. We screw it all the way around. Our latches are super tight, everything's centered. We still have to put the weather stripping in this one. It's not quite done on this trailer yet, but as you can tell, even by the sound of it, it's a solid door. All our doors are built the same. It just matters of how many hinges we're gonna put in it, how much of a load we're putting in it, determines how big we build the frame. We build every frame one off. So every application's one off. We don't have a standard generic door setup. We build to the customer application. So that varies on the price. All right, so a few other things that the customer had brought to my attention while this thing is here. The back door isn't pulling in as tight. They're custom flush mount latches. They use them for a lot of years. I think they still may use them. I like them when they're installed properly. When they cam in, they're interior cams. As you push them in, it pulls the door tight. Over time though, they wear out, and then the door doesn't suck in as tight. And they're not always reinforced. So if you see, there's some screws that are popping out back here, and that's pretty much from the rock of the trailer. Like when the trailer rocks back and forth going down the road, the box is rocking, and the door is not really acting as a gusset. This door is a nice door. Again, the older trailers, I like how many hinges they use on it. It's held up well. It's a very big door. I think we had a good foundation to do what we need to do here. We're gonna put a little drip edge on the back, get that water to come out over that door, tighten those screws up, and we're gonna slow the rock down in the box. Another thing down here is they installed these skid wheels, which are never really a good thing, and especially when they're not reinforced. As you can see, when they've hit them, it's kind of bent out the main frame here. This was just kind of designed, when they put these plates on from the factory, they're designed just to hold the corner in. They're not really designed to take an extra load, especially when it's 3 inches down, getting run over a curb or something of that nature. There's no reinforcement to hold this plate here. It's just meant to be a skid plate where if you do touch the corner, it slides over it. I don't really like skid wheels. It takes away 3-4 inches of clearance. clearance than on an already low trailer. This customer does want to put bigger axles on it, so we're going to take a look at it. We're going to pick it up here, finish explaining what we're going to do to fix this and how big of axles we can get fit on this trailer here. So let me go ahead and lift it up. We got these lifts, kind of loud. They're rated for 18,500 pounds a piece. They're Lincolnis. Anybody that's used these things know they're absolutely fantastic product. So I went ahead and lined it all up already to the frame. We got 2 in the front, 2 in the back. So when they reach max height of the lift, which is more than comfortable for us, they automatically shut off. They have manual lockouts in them. And now we can go ahead and safely come underneath the trailer and know that we're secure. So if we look at this here, this is what I was talking about. There's only a bent piece of sheet metal that tie all this together. This is what I was talking about for the sides. It's a bent piece of sheet metal on the outside, a bent piece of sheet metal on the inside. It creates a box, which is where we have our problem up in the front. In the back over here, this plate here, you can see it's already starting to crack. It was never designed to have a hold a wheel on it. Whenever we install skid wheels, if we do install skid wheels, we want to get all this tied together. Maybe put a tube back in here, maybe plate this. Another thing is these extensions for these beaver tails. This is your main frame right here. It's a real nice main frame on these older trailers. It's a 3x6, 3/16 wall tubing. Now when they put the beaver tails on these mass production trailers, they just use a bent piece of sheet metal to taper it down. With that being said, what we like to do if we're gonna install some skid wheels is we reinforce this, we box this in, we do something in the nature of transferring the load from the back to the main frame. This to just weld some wheels on the bottom of the stock corners obviously isn't sufficient enough, and most people that do it, they either do it to here or they weld right to here and it bends these over and bends these up because there's nothing to hold this, tie this all in together. Now our customer does want to put bigger axles on it. These frames were they were designed originally from Hallmark. These are 6,000 pound axles, but they'll take a load all the way up to 8,000 pound axles comfortably without any extra reinforcement or gusseting. What they did also back in the day that was good is they did tubed outriggers here instead of just the bent sheet metal outriggers. This is something we do aftermarket on the new trailers, and then we'll put a cross base across if we have a problem with the boxes sagging. After looking at this trailer, we can see that we have enough room here. If we're looking to an axle upgrade with torsion axles, there's no springs. I'm just looking to see what it's going to take to get this bracket changed over to an 8,000 pound capacity. We're going to be dealing with a bigger drum, a bigger arm, a bigger tube. We have to look and see if the main frame is straight and hasn't been overloaded to the point where that got affected, and we need to address that. We're going to take some measurements. These axles, you can see here, we're lucky enough to get the old axle markings. It says our hub face is 95 inches. Our outside bracket measurement is 75 3/4 of an inch. It's a 10-degree upturn axle. We'll use some of those measurements. For our new axles, we're probably gonna have to go about 1 inch wider because I wanna run a little bit bigger tires, some 17.5 wheels, solid steel wheels. These trailers go all over. They go all across the country. So we have to build it. These customers, our customers are primarily motion picture industry customers. When we build something for them, we don't want to see them for a long time and until they're ready to do some maintenance on them, or we don't want to deal with the phone calls of repairs for lack of craftsmanship, I'll just say. All right, so while we got this thing in the air, I'll go ahead and show you the rest of this door, what I was talking about. On the bottom here, when it got hit, we can see that if you look down the frame here, this whole thing got bent in. And this is what I was talking about, where on the newer trailers, this is just one piece of sheet metal. This one has an inside bent piece of sheet metal on the older ones that tied in the outriggers a little bit better. But for these older trailers, the repair on them is kind of a pain because you can't just push it out. We're gonna have to go ahead and, if you look down here, the whole thing's bent in. The door's kind of pushed out. It kind of got bent in and lifted up at the same time. So we're gonna have to figure out how to get this step out. And seeing here, we can't really, this is still pretty straight because it's a whole separate piece. So what we're gonna have to do is out here, we're gonna have to take the piece of trim off like we talked about earlier, re-weld that, buff that in because I don't make that anymore. I go ahead and look at how the tongues are, bracing, the gusset plates. Again, this is an older trailer, so they did more gusseting. This is the way we build them currently still, as we add extra plates. Sometimes we cut our tongues in, but this is plated on both sides. So it's welded here, and it's welded here with a 3/16 inch plate, a 3/16 piece of angle to catch the front. This is a really nice tongue. The only difference in how we do it and what they do is they just use a piece of sheet metal to catch the third member. We actually use a piece of tubing. We come back a little bit farther, and then up in the front, we'll make this a piece of tubing as well to tie the whole front end in together. Again, for a mass production trailer, it's 15 years old. I consider this a pretty high quality trailer. Just something else you want to look at if you're shopping for trailers or shopping for structure. I tell all my customers, shop for structure, don't shop for price ever on a trailer. You always want to shop for structure. You always want to look for cracks, fatigue, frame sizes, how corners are built. This has cast corners. There's a lot of these little details that you're gonna see were a higher quality years ago when they all competed for who can build the best trailer instead of who can build the cheapest trailer and get the most money out of it for their investors. So to show you the difference in our trailer builds and others' mass production builds, mass production uses a lot of bent sheet metal. There's pros and cons to all of it, but if you'll see on this one, over time, it's flexed here, it's kind of bent here, it got pushed back here, so it doesn't hold its integrity as well, versus our builds, all tubing, always stay square, always stay straight. If it does get hit or in an accident, we can see it immediately. But on these bent ones, it's hard to tell until you get into full detail. If something does happen to them, it takes a lot longer to measure everything out, square everything, to figure out where the fail point come from. It could have came from, it just got bumped for something here. This could have come from the flex and the tongue. The tongue comes in here. This is the main frame here. They move. Everything moves on these production trailers. So sometimes, and they're not fully welded all the time. You'll notice in ours, they're fully welded. And by having this boxed in with tubing, it keeps the shear down and less movement. Now in every trailer, you're gonna want movement. Our trailers factor in for movement. These just have an excessive amount of movement that personally we don't like, but there's pros and cons to both applications. This is the main frame on a mass production trailer. Then you have your outside walls. So our trailer design, we go with our main frame is actually the outside wall frame, and we eliminate the outriggers. The floor joists go all the way to the outside. It makes the wall of the trailer become a giant brace, and then we don't have this situation here where the axles are in this section trying to push up and the box is out here trying to push down. You don't have this 10 to 12 inches of shear going on in our design. I call it an H-box setup. We'll just show you the difference in our framing, but while we're under here, I just wanted to address what an outrigger is. This is your main frame, this is your outside wall. These are the outriggers that connect the two. A lot of mass productions have failures in the outriggers right here at the wheel boxes. If you look in a lot of your trailers on the inside of the wheel box, as you look inside the wheel box right here, you look in this corner right in here, and you'll see it's cracked on a lot of the new trailers. Some of them aren't welded. If you look around, some of them aren't welded, some of them are cracked on the mass production trailers. So you just have something that's just another thing to pay attention to, but it's the biggest difference between how we build and how mass production builds. All right, so let's run around the shop and figure out where we can get all our materials from, what we have laying around, what we need to order. Pretty sure I ordered everything for this project, but I don't know. So I'm just looking here, spray adhesive here. I got some wood under here that we're gonna use for the framing. Let's see, over here, we got some hardware, some screws here. I'm gonna try some different setups with some screws on this door. We're always trying something new. Always seeing if we can make it a little bit better, more efficient, stronger, something of that nature. We have our insulation upstairs. I can run you up there and show you the different applications. We have some sheet metal up here. So obviously you can see part of the timing is to get everything together. We're gonna have to pull this out a little bit, get that sheet metal down. We're gonna need 2 sheets of that. I don't have any drops down here. So let's run upstairs and see what we have for door framing. Kind of got to go through the maze here. This location We're kind of new out here, about 5 years. We're in Los Angeles, California, in the San Fernando Valley for the last 18 years. Right here we have custom cut 1 3/8 thick foam for the inside of the doors. This is some custom cut foam that we have for when we manufacture the trailers. We put them in the walls if it's required by the customer or requested or needed. Some other extra materials we have left over. And right here is where we get into our door trim. If you want to come around over here, I can show you the different styles. So this is what we're going to build the actual door out of. These are all different extrusions. This is actually will be the frame of the door. It'll sit like this. Your screws go in here to screw it in. And this is your other piece that fits in here. That becomes your door. They fit in like this. They're extruded to fit into one another. And we put our weather stripping in there. Our hinges get cut into this strip right here. Let's see what we got here. This is our hinge material. This is our corner material. These corners right here, they fit into, when we build the doors, they fit into the sides. It's kind of hard to see here. So we'll have to cut it. It slides in. That reinforces our corners. Everything fits in together. I'll be showing you guys how it all works when we get to cut. But this is our pile, one pile of door material, one pile of framing material. When you're a smaller shop like us, because we can't buy the volume that we need to, whereas a mass production place that does only doors, you can get a door for $400 or $500. The hardest part about getting a door from one of those places is the shipping. That's the reason why our doors are a little more expensive. So the way we try to compensate for that is adding more reinforcement and more bracing and just better build quality in the overall scheme of things.